All right, so this is our last section for chapter 6 and the last section for the class. And we're going to be talking more about quadratic equations like we've been talking about with factoring and everything we've been doing in chapter 6. And this section specifically focuses on applications of quadratic equations, which means word problems using factoring and quadratic equations. So let's first go through and talk about the steps that you should follow when you're solving a word problem. So steps for solving word problems. And so the first step, and this one seems kind of obvious, and like it shouldn't be written down, but the first thing you want to do is read and understand the problem. So that might mean reading through the problem a few times so that you can really understand what information they're giving you and what you need to figure out. So most of the time I'll go through and kind of underline important parts and kind of go through and do that while I'm reading through the problem. Secondly, we want to define a variable. And so that means we're going to be saying something like x equals some quantity, whatever we're solving for. Or you can draw a diagram. Oops, I can't spell. But this is especially helpful in these problems where we have different quantities that we're solving for, like the length and the width of a rectangle, and we want to know what x is representing. So it's really important that you define a variable. Third step is to write an equation. So based on the information that they gave us, we want to go ahead and write an equation using our variable. Fourthly, we're going to solve that equation. And so that might mean factoring, in this case, because we're talking about quadratic equations. Our fifth step is to state the answer. And the important part here is to include units, because these are most of the time going to have some kind of units that you want to tack on the end of that numerical answer, especially if we're talking about like the length and the width of a rectangle. You should be given units for those. So always make sure you include those. And lastly, check your answer in the original problem. So instead of going back and plugging your answer into the equation that you came up with, you guys want to make sure that it makes sense in the original problem, meaning the words before you wrote down the equation, because you could have written down the equation wrong. That happens all the time. The equations are probably the hardest part of doing a word problem. So you always want to make sure that you check your answer in the original word problem, not just in the equation you came up with. All right, so we're going to go through and just do 3 examples. Not too many. A lot of these are really similar. And so the first one we're going to do here is going to be one of those rectangle questions I was just talking about. And we're just going to solve. So number 1 here, and it's going to take me a little bit to write these out, so bear with me. The length of a rectangular room is 2 meters more than the width. The area of the floor is 48 meters squared. Find the length and the width. So we're looking for two different things here of the room. All right, so with questions like these, sometimes you'll be given a diagram that goes along with it. Sometimes you'll have to come up with that diagram yourself. For this one, we want to first come up with the diagram. And writing or drawing this diagram out isn't required, but I'm a really visual person and I think it's really helpful to kind of draw out what we're talking about. So we have a rectangular room. So I'm going to draw out a rectangle. And we're told that the length is 2 meters more than the width. So for this one, there isn't kind of a right or wrong answer for how you define your variables. We're looking for length and width, so it's going to be one or the other. Sometimes it's a little bit easier defining it as the length or the width. In this case, because we're comparing the length to the width, I'm going to call the width x. So I'll put the x there, and it doesn't really matter which one you call the width, which one you call the length. But I'm going to say that x is the width. And then since we know that the length is 2 meters more than the width, then we know that it's going to be the width, which is x, plus 2 more meters, so plus 2. We're also told that the area of the floor is 48 meters squared. So we need to know the formula for the area of a rectangle. So our area is equal to the length times the width. And so if I go ahead and start plugging in, we know our area is 48. Our length is x plus 2. And then our width is x. So now we have our equation. So we're done with steps 1, 2, and 3 of our steps for solving word problems. Now we can go ahead and start solving this. So if you remember, when you're solving a quadratic equation, first thing you want to do, and we can see it's a quadratic equation because we're going to have an x times an x. We want to go ahead and get this equal to 0. Before we can do that, though, I'm going to go ahead and distribute. It's going to look weird because I'm going backwards, but it's okay. The x is just on the right side. So we have 48 equals x times x is x squared. Oh, my pen is so weird on here sometimes. There we go. And then x times 2 is 2x, so plus 2x. Now we can go ahead and get this equal to 0. So I'm going to go ahead and move the 48 over to the right so that this x squared will stay positive. It'll make factoring a little bit easier. So we get 0 equals x squared plus 2x minus 48, just kind of adding it on to the end because it doesn't combine with either of these two terms. And now we want to go ahead and factor. So 3 terms means we want to use the big X. There's no number in front of the x squared, so this one means we can go straight to the 2 sets of parentheses. And we're going to be multiplying to a negative 48 and adding up to 2. So remember, for these, you can always list out your factors of 48. So we have 1 of 48, 2 and 24. 3 goes into it 16 times. 4 goes into it 12 times. 5 doesn't go into it, but 6 goes into it 8 times. And then 7 doesn't go into it, and we're back to the middle there. So since we're multiplying to a negative, we need a positive and a negative. And because the number that we're adding up to is positive, that means our larger number is positive, and all of these smaller numbers have to be negative. If you kind of can't figure out that way, you can test both of them being positive and negative. You just have some more pairs to test out. But if we go through and add all of our pairs up, the pair that gets us to a positive 2 is -6 and 8. So in our little factor groups over here, we're going to have x minus 6 and x plus 8. Remember, it doesn't matter what order those go in. And then we're going to go ahead and split these up. So we split these into our two equations. We get x minus 6 equals 0, x plus 8 equals 0. And if I solve both of those for x on the first one here, we get x equals 6. And subtract 8, we get x equals -8. Now, we don't want to go ahead and just box these straight away, because we are talking about a word problem. We are looking for the length and the width of the room, and we defined x to be the width. So this x down here, one of them, is going to represent the width. We're still going to have to find the length, but since we're talking about the width, we can't have negative length. So this one here on the right, x equals -8, is not going to work because we can't have negative length. So I'm going to go ahead and just cross that one out. X equals 6 is going to be our width. So we know that our width is 6, and then what units would go on this? Well, our area was in meters squared, so this is 6 meters. And our length is, well, our length was 2 meters more than the width, so x plus 2. And so it's going to be 6 plus 2, which gives us 8 meters. And then just kind of checking this in the context of the original problem, so not looking back at our original equation, just in case that was wrong. The length, so we have our length right here is 8, is 2 meters more than the width. And our width was 6 meters, so 8 is 2 meters more than 6. So that part's good. And the area of the floor was 48 meters squared. Area, length times width, 8 times 6 is 48. So that also works out. So our solution here is good, and we fully answered the question. So that's generally how those kind of rectangular room problems are going to go. Sometimes it'll be a garden, some other room or shape, but it's always going to be a rectangle. All right, so let's go ahead and try another type of problem. This one is another really common problem type. And this is one that we've seen before, we just haven't seen it with quadratics. So this one says the product of two consecutive even integers is 4 more than 2 times their sum. Find the integers. All right, so looking through this again, we have the product of two consecutive even integers. And so just focusing on that part first. Consecutive even integers, you want to think of numbers like 2 and 4 or 10 and 12, two even integers that come one right after the other. And so if we were to come up with an expression for these, let's pick the numbers 10 and 12 as just an example. I'm going to call the first one x. So x is our first integer. And our second one, if we want to get from the first even integer to the second one, how do we get from 10 to 12? Well, we're going to add 2. So our second integer is going to be x plus 2. So this is kind of how I'm going to define our variables here. And then we can go back to the problem and see what else it says. So it says the product of these two consecutive even integers. So the product means we're multiplying. So x times x plus 2 is, remember, is means equals. We'll put an equal sign here. 4 more. So 4 more means we're going to add 4, then 2 times their sum. So we're going to take 2 times their sum, and then we're going to add 4 to it. So if we have 2 times their sum, well, their sum is x plus 2. And then we want 2 times that sum. So I'm going to take that entire sum, multiply it by 2. And then we want 4 more than that, so we're going to add 4. So this is the part that gets kind of confusing because we have all this stuff going on. But if you kind of break it down into the little parts, it's not as bad. It's a little bit more manageable. So we have our equation done. Now we can go ahead and solve this one. So first thing we want to do is simplify both sides, and then we can go ahead and get it equal to 0. So I'll distribute on the left. We get an x squared plus 2x. On the right-hand side, we can distribute. We're going to have to combine some terms. So we get 2x plus 2x plus 4 for the 2 times 2, and then plus 4 that we have at the end. Now let's go ahead and combine like terms on the right side before we start moving things around. So the left side is still x squared plus 2x. And now on the right, 2x plus 2x is 4x. 4 plus 4 is 8. And now we'll go ahead and move everything over to one side so that it's equal to 0. The left side is a little bit nicer so that this x squared stays positive. So I'm going to go ahead and subtract 4x from both sides. And if you wanted to do this in one step, you totally can. So we get x squared, 2 minus 4 is negative 2x, and then equals 8. And then I'll move the 8 over to the left. It doesn't have any like terms though, so we're just going to kind of add it on to the end. So x squared minus 2x minus 8 equals 0. And now we're at the point where we want to go ahead and factor. So again, we have a nice trinomial with a coefficient of 1. So big X, we're going to multiply to a negative 8, add up to a negative 2. Make sure you include those signs. So multiplying to a negative, again, we're going to need a positive and a negative. So we either have 1 and 8 or 2 and 4. 2 and 4 have a difference of 2. So it's going to be 2 and 4, and the 4 has to be negative. So we're going to go ahead and factor this into x plus 2 and x minus 4 equals 0. And if we go ahead and split these up, I'll do this over to the side here. We get x plus 2 equals 0 and x minus 4 equals 0. Solve each one of these, and we get x equals negative 2 and x equals 4. Oh, I didn't add the 4 on that one. There we go. So we have what our x is equal to. All right, so if we remember what our x represented, X was the first integer. And so since we're talking about integers, and specifically even integers, integers are positive or negative whole numbers. So they don't have any fractions. And if we look at the answers that we got here, we got x equals -2 and x equals 4. Those are both even integers. Even though one of them is a negative, since we're not talking about the length or the width of a rectangle here, we don't have to disregard this. So we are going to have two different answers. First thing we're going to do is we're going to go ahead and find our second answer with x equals -2. So if we go ahead and find our second consecutive even integer, we defined that to be x plus 2. Just two numbers higher than our first integer. And so in this one, our first integer is -2, and if we take our x and add 2 to it, then we're going to have -2 plus 2, which is 0. And so our first answer here is going to be the numbers -2 and 0. Both of those are integers and they are consecutive even integers. And now if we go ahead and look at our second answer using x equals 4, again, if we take x plus 2 to find our next consecutive even integer, we're going to take 4 and add 2 to it, so we get 6. And so here our consecutive even integers are 4 and 6. So these, if we were to go back and look at them in the context of the original problem, they both work. So just remember, unless you're talking about the length or the width or something that has to be positive, we can have negative integers. So this is perfectly fine in this case. All right, so now let's go ahead and take a look at another consecutive integer problem. I want to do this because, let me see if I can add another page here. It doesn't want me to add a page. All right, so I'm going to have to just clear this first screen here. So it's not letting me add another page. There we go. Okay, so our next example here, and this will be our last example, but I do want to go over some triangle formulas with you guys. So this last one, I want to show you because it sounds a little weird, but it's kind of similar to the one we just did. So number 3, they want us to find 3 odd consecutive integers such that the sum of the squares of the first and second integers is equal to the square of the third integer plus 33. Oops. All right, so let's go ahead and break this one down again. So we have 3 consecutive odd integers. So if we go ahead and look at consecutive odd integers, if I were to write down an example, that would be something like 3, 5, and 7. We have 3 of them this time. And so just like usual, we're going to go ahead and call the first one x. So this is our first odd, I can't write today, integer. And then getting from our first integer to our second one, just like with even integers, we're still going to add 2. So our second integer here is going to be x plus 2. And then to get from the second one here to this third one, we're going to add 2 again. So if we have x plus 2 and we add 2 to that, we have x plus 4. So we have our integers kind of defined down. We have expressions for them. Now let's look at what they told us in the problem. So the sum of the squares of the first and second integers. So the squares of the first and second integers, square means we're just going to square it. So we're going to have our first integer squared, our second integer, which is x plus 2 squared. So make sure you square that entire quantity. And then we have the sum, which means we are going to add these two together, is equal to, remember that just means equals. So equals the square of the third integer. So the square of the third integer, just like we did with our other two integers, we're going to take our third integer, which is x plus 4, and we're going to square it, and then plus 33. So just adding on 33 at the end. So now we have our equation all set up. We want to go ahead and simplify it. So if I go ahead and square these two expressions here, you want to be really careful because we can't just square each of these terms. Remember that squaring means that we are taking whatever number or expression that we have and we're multiplying it by itself. So x plus 2 times x plus 2. Same thing on the right, x plus 4 times x plus 4. And then plus 33 at the end. Now, if I go ahead and FOIL this all out, I'm going to have x squared still in the front, plus x times x is x squared, x times 2 is 2x, 2 times x is another 2x, 2 times 2 is 4. The left side is good. Now let's look at the right side. X times x is x squared. X times 4 is 4x. 4 times x is another 4x. And 4 times 4 is 16. Bring along the 33. And now we have a bunch of terms here. Let's go ahead and simplify a little bit. Looking at the left-hand side, we can combine our x squareds and our 2x's. On the right, we can combine our 4x's and the 16 and 33. So let's go ahead and do that. So x squared, 1x squared plus 1x squared is 2x squared. 2x plus 2x is 4x plus 4. On the right-hand side here, we have an x squared plus 4x, and 4x is 8x. 16 plus 33 is 49. Now, let's go ahead and get these all onto one side. Again, I'm going to move it all over to the left so that this x squared is going to stay positive. Makes it a little bit easier for factoring. And I'm going to do this all in one step. So I'll subtract x squared from both sides. So 2x squared minus 1x squared is x squared. And then we have 4x, we're going to subtract 8x from both sides. So this becomes a negative 4x. And then we're going to subtract 49. And my pen's making random marks. Oh, and I forgot to switch it back. There we go. Subtract 49, we get negative 45 equals 0 because all of those terms are gone. All right, now let's go ahead and factor. 3 terms, use the big X, multiplying to negative 45 adding up to a -4. If we were to go through all of the factor pairs here, the ones that have a difference of 4, because we need a positive and negative, are 9 and 5. And the 9 has to be the negative one to get that -4. So we have x minus 9 times x plus 5 equals 0. And then remember, our next step is to split these up. So we get x minus 9 equals 0, x plus 5 equals 0. And then if we solve each of those, add 9 to the first one, we get x equals 9. Subtract 5, and we get x equals -5. And just like on the last problem, since we're talking about consecutive integers, we're not talking about lengths, positive or negative numbers work for these. So we're going to have two different answers. One is going to have 9 as our first consecutive odd integer, and then x equals 5 is going to be -5, sorry, is our second one. And so for these, I'm going to do it more based on not plugging in 9 here, but since we're talking about consecutive odd integers, and this is our first one, the odd integer after 9 is positive 11, and then 13. So you're just going to go up in your consecutive odd integers. You could also do the x plus 2, because that would be 9 plus 2, which is 11. Same thing if we were to add 4, 9 plus 4 is 13. So it would get you the exact same answer. But if you don't want to show this work, you didn't have to. And then with our -5, if we start at -5 and go up, so we're becoming less negative, we get -3 and then -1. So make sure with your negatives, you're not becoming more negative, because that would not work in our original problem. So again, two different answers here. From -5 to -3, that would be your x plus 2. -5 to -1 would be your x plus 4. All right, so those are kind of the most common types of questions. We also are going to have some triangle questions. And for those, I'm going to give you guys some important kind of formulas, and then we'll be done with section 6.8. So some triangle formulas, and there's just two of them. We've discussed these before, so you should have these. And you might know them from previous classes anyway. For the area of a triangle, we're going to have 1/2 times the base times the height, or just 1/2 BH. So that's our first formula. And then our second formula is Pythagorean's theorem. And Pythagorean theorem is, if we're given a triangle, a right triangle, with our two legs, A and B, and remember, these can also be switched. It doesn't matter which one goes where, but C is the hypotenuse, the longest side across from the right angle. Then our Pythagorean theorem is A squared plus B squared equals C squared. And just remember, if you were given, let's say our hypotenuse, we should have a problem like this, is, let's say, x plus 2. Just remember, when you plug stuff into something squared, you have put it in parentheses, so you would have x plus 2 squared, just like we did on the last problem. All right, so that's it for chapter 6. That's it for Math 95. And so the homework assignment for this week is only going to be about 11 problems, I believe. It's shorter compared to your other assignments. Final exam is on the 12th. It's on a Saturday, open all day, so make sure you make time for that. It'll be 45 questions. you'll be given 2 hours to complete it. And then a review is posted, or is going to be posted. Nope, it will already be posted by the time you see this video. All right, so I hope you guys have a great winter break, and I will maybe see you guys in Math 96, either over winter or next semester.